since it is multidisciplinary, so we have three experts from life science, architecture, and social science.
Yeah, yeah. Good.
But our theme is common, that is sustainability.
Yeah, yeah. Okay. Sustainability, yeah. I also talk about sustainability for some time.
Yes, yes, yes. I have seen your abstract.
Yeah. Your students have not come yet, right? Started coming or they are not
Yeah,
coming?
they have started coming now.
Yeah, yeah. A problem is to ensure, social distancing is a problem in the classroom.
Yes, even here, we have been allowed to call them for practicals and other things to the laboratories.
Yeah,
But that is also 50%. But problem is our hostels are not open yet.
yeah, yeah. That's also another thing.
So many of the students who are outside the city cannot join us.
Yes, yes.
So we are.
Maybe, yeah. Maybe
Yeah.
once the IIT is doing all its lectures, etc., all in, online, all lectures, practicals, everything.
Tripathi sir, practicals, we are also doing it online, but we are not very happy about that.
Yeah, yeah. What else you do? What to do? Maybe
Yeah.
final year students, could come and do online practicals. That's all.
That is the thing, because unless they come and work in the laboratory, they won't have the feel of that.
Yeah, yeah. Final year students should be there at least final semester.
Yeah, for science and engineering, unless they come and work, and even architecture.
Yeah, yeah. Same thing at the
Yeah.
end. Yes. I'll join with you 1 minute. Just
Yes,
leave for
yes,
1 minute.
please. Yes, please. Yes, please.
Madhura ma'am, good morning. Yatindra sir, good morning.
Good morning, good morning, good morning.
Good morning, Adi sir. Good morning, Guru Prasad sir. Good morning, everybody.
Yes, good morning,
Good
ma'am.
morning, good morning.
Waiting for people. Who else will be joining?
Sir, Tripathi sir has not joined yet.
Tripathi sir has joined. He has just left for 1 minute. He's here. He's here.
Let me ask from Madam Dhar.
Yeah, please. We are waiting. Maybe we can start. Okay.
Yes, sir. Ma'am, good morning. Sir, Madam will be joining us soon. We can start once Tripathi sir joined the session.
Yes, yes. Professor Tripathi has just left for 2 minutes.
Okay, sir.
He was here and he will be joining.
Ji, sir.
My name is getting displayed in his this thing also, because I sent him the link.
Sir, he can rename from his end. Now
Yeah.
he can rename from his end.
Yeah, that's what I was seeing. Why my name is.
Ma'am, he might not be that savvy with this system, so we'll have
Okay,
to
let
guide
it be
him.
like that.
Huh. Sir, by clicking on his window, right clicking on his window, he can rename.
Shadab sir, is it possible for you to rename?
Yes, ma'am.
Sir, please do it.
Please rename. Don't rename me. Please see whom you are renaming.
Sir, he is Dr. B.C. Tripathi.
Yes, Dr. B.C. Tripathi.
Shadab sir.
Okay, Tripathi sir, you are back.
Yeah.
Okay. Shweta, we can start now.
Sure, sir. Okay, sir. Honorable dignitaries, learned delegates from corporate and academia, a very good morning to one and all. I feel privileged to welcome you all to the third day and the third plenary session of Sanmantrana 2021, a multidisciplinary international congress on good practices and capacity building for sustainable development goals. As it is very well quoted by the Nobel laureate Sir Kofi Annan that our biggest challenge in this new century is to take an idea that seems abstract, sustainable development, and to turn it into a reality for all the world's people. Keeping this in mind, this plenary session 3 of Sanmantrana 2021 aims to bring the best brains together from all around the world to talk about the cutting edge innovations so as to achieve the goals of sustainable development smoothly. This session will be chaired by Dr. K. N. Guruprasad, Director, Sri Vaishnav Institute of Science, and the co-chairperson for this session is Architect Vishal Yadi, Director, Sri Vaishnav Institute of Architecture, Sri Vaishnav Vidyapeeth Vishwavidyalaya. The distinguished speakers of this session are Dr. B.C. Tripathi, Professor Emeritus, Department of Life Science, Jawaharlal Nehru University, New Delhi. Dr. Madhura Yadav, Professor and Director, School of Architecture, Manipal University, Jaipur. And Professor Yatindra Singh Sodhya, Director, MP Institute of Social Science Research, Ministry of Human Resource Development, Government of India, New Delhi. I extend my warmest welcome to our honorable speakers, chairperson, co-chairpersons, dignitaries, delegates, research scholars, and students. Now, I would like to introduce to our attendees the first speaker of this session, Dr. B.C. Tripathi, Professor Emeritus, Department of Life Science, Jawaharlal Nehru University, New Delhi. Dr. Tripathi has worked for his PhD on primary processes of photosynthesis and plant productivity at the School of Life Sciences and Environmental Sciences, JNU, under the supervision of late Professor Prasanna Mohanty. He has worked on bioenergetics of chloroplast and mitochondria at the Ohio State University, USA, as a postdoctoral researcher. Subsequently, he moved to the University of Illinois and worked upon heterogeneity of chlorophyll biosynthesis. Later, he joined School of Life Sciences, JNU, New Delhi, where he started his photobiology laboratory. His discovery on suppression of photomorphogenesis by red light mediated by phytochrome A is novel and interesting. He has cloned the PORC gene and demonstrated its function in chlorophyll biosynthesis. He has overexpressed porc gene in Arabidopsis and mustard for resistance of plants to photodynamic herbicides and salt stress condition. He has been associated with the Ravenshaw University, Cuttack, Odisha as the Vice Chancellor, and he has also served as the Dean School of Life Sciences, JNU. He has worked for the National Aeronautics and Space Administration, NASA, Kennedy Space Center, US, and has worked upon space-grown plants and studied the effect of zero gravity on photosynthesis that could generate oxygen for human survival in space. He has till now authored over 100 research articles and patents and is on the editorial board of different national and international journals. He has mentored 27 PhD students and a large number of MPhil students so far. Professor Tripathi was elected as a Fellow of the Indian National Science Academy in 2005. He is also a Fellow of National Academy of Sciences and National Academy of Agricultural Sciences. He is a recipient of J.C. Bose National Fellowship of Government of India. His name appears in Marcus, Who is Who in the World. He is a recipient of Rockefeller Foundation Biotechnology Career Award, USA. He is also a recipient of Samantrana Shekhar Award in Science, Gold Medal for Outstanding Contribution to Science by Shrivastava Foundation, Lucknow, Professor P. Parija Samman, and many more. It is a Herculean task to sum up such a dynamic personality in words and time. We welcome you, sir. Now, I request Dr. Raksha Chauhan, Associate Professor, Sri Vaishnav Institute of Architecture, to introduce our next speaker. Raksha, ma'am.
Please unmute yourself, Dr. Raksha.
It's an indeed pleasure and honor for me to introduce Professor Dr. Madhura Yadav, architect and urban planner on this plenary session 3 on the occasion of Sanmantrana. Dr. Madhura is an architect planner over the last 2.5 decades. She is associated with the administration, academics, and research. She is founder head for all design and planning programs and currently acting as director, School of Architecture and Design, Manipal University, Jaipur. She is actively involved as an expert in UPSC, AICTE, COA, and DST Rajasthan, and also a certified member in CBPR. She has also received keynote address on sustainable architecture and planning, design of smart villages, sustainable rural development, sustainable materials, etc. in various university and government organizations. She has also contributed as a team leader for preparation of city development plans of towns, heritage conservation of forts, and slum rehabilitation projects in Maharashtra. She has several publications in international conferences and journals and currently guiding PhD scholars. She is responsible for strategic plan and policies as per vision and mission of university. She is a hub coordinator for community-based participatory research and handling various responsibilities at university level. She is a recipient of Asia Pacific Global Award 2017, Distinguished Faculty in Architecture Award 2017, Global Outreach Education Award for Excellence in Teacher in Architecture 2018, Best Presentation Award Canada 2018, Education Leadership Award 2019. On behalf of his Triple V fraternity, I welcome you, respected madam. Now may I request Professor Shweta to introduce next guest.
Thank you, ma'am. The next speaker of this session is Professor Yatindra Singh Sodhya, Director, MP Institute of Social Science Research, Ministry of Human Resource Development, Government of India, New Delhi. His areas of interest are democracy, decentralized governance, electoral politics, tribal issues, and developmental issues. He has participated in more than 240 seminars, workshops, and conferences of national and international importance in India and abroad. He has also contributed to the leading newspapers like The Hindu, The Indian Express, Hindustan Times, and many more. He has coordinated more than 70 seminars and workshops, and particularly continuously coordinating training courses and capacity building programs on research methodology in social sciences for more than 2 decades. He is guiding research leading to PhD degrees in political sciences from Vikram University, Ujjain, and 18 candidates have been awarded degrees under his supervision. Dr. Sodhya is editor of many national and international journals. He has authored many books, monographs, published research papers. He has completed more than 45 research projects for central as well as state ministry. He has been conferred with Professor G. Ram Reddy Social Scientist Award in the year 2017 for his substantial contribution of research in the area of Panchayati Raj and grassroots of democracy. He is also a member of Indian National Commission for Cooperation with UNESCO under Subcommission on Social Sciences constituted by Ministry of HRD. He has been member of research committee, review missions, editorial boards, and life member of various institutes and organizations of national and international repute. The plethora of achievements of Dr. Sodhya couldn't be summarized in few words. Here I have tried a little bit. We welcome you, sir. Moving on to the chairperson for this session, Dr. K.N. Guruprasad, Director, Sri Vaishnav Institute of Science, Sri Vaishnav Vidyapeeth Vishwavidyalaya. Dr. Guruprasad has worked as Professor of Life Science at DAVV and is presently Director, Institute of Science at Sri Vaishnav Vidyapeeth Vishwavidyalaya, Indore. He has a vast teaching and research experience of more than 36 years, being well known in the field of photobiology and magnetobiology. He has guided more than 25 PhD students and published 80 research papers in journals of national and international repute. He has undertaken many research projects with UGC, DBT, and DST. He has also been associated with the Kobe University, Japan, and Moscow University, Moscow as visiting scientist. We welcome you, sir. Now I request Dr. Raksha Chauhan, Associate Professor, Sri Vaishnav Institute of Architecture, to introduce our co-chairperson. Raksha ma'am, please unmute yourself.
Thanks a lot, Shweta ma'am. It's an honor for me to give introduction about Professor Dr. Vishal Yadi. Dr. Vishal Yadi is an architect, academician, and researcher with more than 20 years of experience. He is currently acting as professor and director in charge at Sri Vaishnav Institute of Architecture, SVV, since last 4.5 years. He has also worked as principal at SDPS Women's College, Indore, and Pravara College of Architecture. Till date, he has worked on more than 50 architectural projects, including coordination of industrial building for Sipla and commercial malls and Mumbai. Other projects include residential, commercial, and interiors, including few turnkey projects. He has also conducted various seminars and workshops for the architect, engineers, building supervisors, and faculty members of academic institutions. His area of interest are construction quality control and energy efficient buildings. He was part of Global Enrichment Symposium Malaysia, where 21 participants of architecture colleges from India were invited. Professor Yadi has been on the panel of reviewers of several academic as well as professional competitions also. He has served on the panel of experts maintained by SNDT University, Mumbai. He has also been a member of the Indian Institute of Architects, Indian Institute of Interior Designers, Board of Study SNDT University, Faculty of Study and Academic Council of Sri Vaishnav Vidyapeeth Vishwavidyalaya, Indore, and Chairman of Board of Studies of Architecture at SVV. He has also inspected several architectural institutes as an expert committee member appointed by Council of Architecture for UG and PG programs. He has worked as jury member for prestigious awards like Architect of the Year and Best Dream House. A warm welcome to this respected Dr. Vishal Yadi, sir. Now again, I hand over session to the Shweta ma'am.
Thank you, Raksha ma'am. Now I request our chairperson and co-chairperson to welcome the guests and start this session.
Thank you, Shweta. It's my honor to welcome our guests today, guest speakers, Professor Tripathi from JNU, Dr. Madhura Yadav from Manipal, and Dr. Yatindra Singh Sodhya from MHRD Delhi. This conference is an annual event we conduct in collaboration with St. Cloud's State University of USA. It's an interdisciplinary conference. As you can see that we have drawn three eminent people from three different areas today to speak on the main topic. The main topic chosen for this year is the Sustainable Development Goals. Sustainable Development Goals, because this topic has been consciously chosen since this has been the buzzword these days in every area of research. Sustainability, when we say sustainability, it is defined as the ability to be maintained at a certain rate or level. In the context of our planet, what it means is to for maintaining an ecological balance, to avoid depletion of natural resources. This is what sustainability means to us. Now, why we are talking so much about sustainability these days is sustainability basically is a biological phenomenon for maintaining ecobalance on this planet. And since I work in plant science, I must mention that the plants are the best sustainable, eco-friendly organisms on this planet. Now, we have to talk about sustainability now because of the threat to the sustainability or threat to the eco-balance due to anthropogenic activities. Now, anthropocentric activities have greatly disturbed this eco-balance in almost all areas, and and the topics which scientists are dealing with or people in other fields are dealing with is to how to restore this eco balance back to the normal, because that is what is required for our sustenance and continuation. In other words, this is kind of retracing our steps to nature and consciously make our effort, although we are moving towards Industry 4.0, which is identified as a phase where artificial intelligence, IoT, big data analysis are all going to be part of our industrial progress. But along with it, we need to consciously pursue simultaneously the fields like alternative energy sources, eco-friendly materials, biodegradation, and the related areas which will help us in sustainability of our development. Now, this is the reason that we have chosen the theme of sustainability for this year. We have three eminent speakers. Professor Tripathi will be speaking on impact of climate change on biodiversity and agriculture. As you have heard from his introduction, that he is an expert in the field of photosynthesis, a basic requirement for crop yield and productivity. Now, Dr. Madhura Yadav will be speaking on energy conscious architecture and planning. And Professor Yatindra Singh will be speaking on sustainable development goals, rural development, and grassroots governance issues and concerns. So we are thankful to all these three experts from three different areas to give us their own perspectives about future development, our goals in the light of sustainable development. With this, I invite Professor Tripathi for his lecture. Dr. Tripathi, sir. Dr. Shweta, is there any problem with Dr. Tripathi?
So let me just check. Hello. Shadab, sir. Shadab, sir.
I don't see him on the screen.
Yes, sir. He is not visible due to some reason. So could you please call him if possible?
Yeah, I'm just calling him.
Yes, sir. Yes, sir. We'll wait for a few seconds.
शादाब सर, वो वैष्णव त्रिपाठी जी को पैनलिस्ट में ऐड करो, पैनलिस्ट में नहीं है वो, है ना? आप लिस्ट में चेक कर लीजिए एक बार। हाँ, बीसी त्रिपाठी उनको प्लीज पैनलिस्ट में ऐड करो। ओके ओके ओके। हाँ, मैं कॉल करती हूँ, कोई बात नहीं। मतलब पैनलिस्ट में है वो।
Guru Prasad sir, or else we can start with the second presentation.
Yes, sir. Just a minute. Hello, sir. You are not on the screen. Okay. Sir, please connect again. And meanwhile, we will have the second speaker. Okay, sir. Sorry for the technical disturbance. Professor Tripathi is having some problem. Can we go with our second speaker, please? Yadi, sir.
Yeah, Madhura ma'am.
Yes, yes, yes.
Can you start, please?
Yeah, yeah. 1 minute. I'll just share the screen. Can you see my screen?
Yes, yes.
Okay. Thank you.
Yes, madam, you can continue.
Yeah. So, good morning to all, and I'm thankful to university for calling me for giving the lecture on sustainable development goals, and especially Professor Yardi. So I'll start with my presentation. Since the conference is about sustainable development goals, so I have decided to talk about energy conscious architecture and planning. So the structure of presentation will be introduction, then the factors affecting energy consumption in building. Then I will be giving some case studies of buildings and cities also. Then 2-3 examples of low embedded energy materials, and then the concept of eco skyscrapers, and then how we should do a capacity building. Now to start with, I think we all are familiar with this picture in pandemic after March. And these pictures were there in the newspaper, and suddenly after this lockdown, we came to know and we can see that we were inside the house and we were locked and the animals were on the roof. So these pictures are giving a very strong message that this planet belongs to all. It is not only not only belongs to human being, but this planet belongs to all the plants, the materials, other flora and fauna, and human beings. But we have disturbed to such an extent that we can't see the animals, and then we are this human development is dominated. So I was very touched by these pictures in the pandemic, and then this makes us think, so how we can build our cities and how we can build our buildings so that this planet will be for all, not for only human beings. Now, if we can see in architecture or cities, in buildings, there are 2 types of energy. One is called as embodied energy and another is called as operational energy. So if we look at, so if we look at the picture, the life cycle energy use of buildings, the 80 to 90% energy used in as operational energy in building and 10 to 20% as a embodied energy. So basically what it means that embodied energy is the sum of all the energy required to produce certain kind of building materials which are going into the building. And operational energy deals with the amount of renewable or non-renewable energy required to maintain the building functions and occupant activities such as HVAC systems in the buildings. So now I will be talking about what are the factors affecting energy consumption in buildings. So when we design buildings, there are three things which we have to consider. That is, what is the context of a building, then the needs and what kind of form we need to give generate for that particular building. So as we can see from the picture, there are various parameters related to this. The context is like we have to see the microclimate, then biological factors, the transport networks, utilities, zoning of the spaces, different spaces, in what neighborhood we are there, and what kind of site is available to construct that particular building. Then we have to address the needs of the users. So what are the objectives, then what are the activities, then space requirement, the relationship between the spaces, then what are the priorities of the users, the access points, the indoor environmental factors, and the maintenance. And then we generate the form, so which will be basically it will be derived from the environmental controls, then the circulation, then the structure of building, the image of the particular city in which we are constructing that building, what are the types of construction, then construction processes, acoustics, daylight, and building envelope is the most important part.
I'm now connected, okay?
So based on these parameters, there are certain factors which affect the energy consumption in buildings. One is site, then building orientation, then building envelope, and building configuration, building components, and then building materials. So I'll go one by one. Now, if we go to the site, we can see the site also there is various landforms are there, vegetation is there, water bodies are there, and the open spaces.
Ma'am, sorry to disturb you. Please, ma'am, just a minute, just a second. May I request all other panelists to please keep their mic on mute mode. All other panelists, please keep your mic on mute mode. Yeah, ma'am, please continue. Sorry.
Yeah. So the first aspect is site, which we have to respect to the site wherever we are developing our cities or the buildings. So there is certain landform on the site, that is topography, then the vegetation, then the water bodies are available, then the open spaces, and then we have to design our cities. Now, if you can see in the picture, I have just given the two pictures. There are so many, but with the Indian context, I have given these two pictures. This is the first planned city of India, that is of 18th century, the Jaipur city, walled city of Jaipur. So if you can see from the plan, the city has respected the topography of the place, and it has been it was designed with respect to the solar and wind direction, solar path and the wind direction of the place. And that's why, as Dr. Guru Prasad has rightly said in the beginning, what is sustainability? It is to sustain and to maintain the ecological balance. Now you can see, if we look at the city of 18th century, designed in 18th century, when there were no formal education of city planning, there was no formal education of architecture, but still this city is sustaining till today and addressing the needs of the present generation also. So this is sustainability, and we have to take the examples of this from our own own heritage. So a few years back, it was also identified as the World Heritage City. And again, if you look at the second city, which has very well responded to the climate and the resources and the culture of the place, both the cities rather. It is Jaipur and Jaisalmer, and there are many more like Shahjahanabad or Bhubaneswar or Madurai towns. And these towns, the city plans not only respected the regional determinants, that is culture, climate, and resources of the place, but the human dimensions, which is the most important dimension of the city planning. They have responded to that also. So when we design the cities, we have to respect to the site. We have to see the vegetation. We should not disturb the vegetation. We have to see the water bodies. We have to take that water bodies into the design of the cities. And then this is not the demolition of the vegetation, or we have to reclaim the water bodies. We have seen in the flooding at Chennai and Mumbai, we have reclaimed the land. So the flooding is the result of that. Now, the second aspect is building orientation. It is very important. I think this is prevention is better than cure. We design the building and then we think of how can we sustain this building in extreme calamities like earthquakes or flooding or any other. So when we we design the buildings and we put ACs into the buildings to keep the buildings like warm in winter and the cool in summer. So if we take into consideration, the building orientation is the most important aspect. With respect to the climate of the place, we have to orient the building. And if we orient the building as per the climate, then we can keep our buildings cool in winter and warm in summer. That is possible. So orientation is a very, very important aspect while designing the building. So it is different in different climatic zones. Like in hot, dry climate like Jaipur, we have to avoid the building surfaces east and west to avoid the extreme sun, and then we can give the longer direction of the buildings on southern and northern side to take the diffuse light. So in other climate like sunny, cold, cloudy like Shimla, Leh, Ladakh, it is different. There are different parameters, and we have to use the active and passive techniques while designing the building. So building orientation is very important aspect. And then as per the use of the building, we have to decide, like, for example, we can take the example of a residence. So we have to decide in which space we want morning sunlight, in which space we have the evening solar radiations we have to alight. As per that, we have to decide the space activities of the building also, which side we have to give which activities. Now, if we go to the building envelope is basically nothing but roof, wall, and fenestrations. That calls a building envelope. So if we can look at the figure, a building envelope is responsible for 26% of the energy consumption. And then there are two pie charts, like for single story building, how each component will contribute to the energy consumption, like wall, then roof, then fenestration is window and doors. So this is the example for multi-story building. You can see that the maximum percentage is from wall energy consumption. So if we decide that we have to construct the wall in a particular way and with respect to the climate, then we can achieve the energy efficiency in a building. Now in building configuration, if you can see, the heat exchange between building and its surroundings occur mainly through the skin of the building. And then we can configure the geometry of the building as per the climate and usage so as to control the magnitude of the heat flow. So there are different aspects of building configurations, elements. So the most important and first priority is shape of the building. Like in which climate you can refer which kind of shape of the building. It's a very important aspect. So while designing the building, we have to decide the shape of the building. Then locating less used spaces such as store in the direction and that force prevailing cold winds. Like which kind, how we can allow the natural ventilation into the building. So we should not block that particular site from where the wind direction is there. That we have to decide where to give the arrangement of openings also. What kind of openings are allowed, what side we have to get, like east, west, or south or north as per the climatic zones. We have to decide as per the wind direction so that the wind can flow into the building. What we do actually, we never decide this then and then put the doors and windows on the particular direction and we block the natural wind flow in the building. So that is not the correct thing. So we have to decide the location of the openings, then size of the openings as per the area of the space. And then again, the important thing is what kind of material you are using for that particular openings, like steel or aluminum or wood or any other material. Then we have to give the shading devices also. If we decide the positioning of the doors and windows, then for windows, we have to decide what kind of shading devices we should use if there is a extreme. And if there is a cold and sunny or cold cloudy, for that also we need to decide if we have to give the solarium or other kind of passive techniques. So these are the important aspects, like using buffer spaces, then locating less used spaces such as store in direction, then exposure minimum. We have to decide as per the climate. In hot dry, we have to minimize the exposure, and in cold and cloudy or sunny cold climates, we have to maximize the exposure to solar radiation. And then the shape of the building and arrangement of openings. Now the building components. The nature of building envelopes determine the amount of radiation and wind that will enter in the building, and it consists of the following elements. Roof is a very, very important aspect because maximum solar radiation enter into the buildings through roof. So while deciding the roof of building, we have to decide the different parameters, that what shape of roof you need, whether it is a flat roof, whether it is a vaulted roof, whether it is a pitched roof. Like if the rainy areas are there, we have to decide the pitched roof. Then if the hot and dry climate is there, vaulted roofs are proved to be better because of the vaulted roof, the solar radiation entering into the building can be minimized. Then flat roof, where maximum solar radiation can go into the building. So shape of the roof is also very important. Then the construction material used for the roof. We have to use the appropriate material for the roof, and then construction techniques like roof pond technique or the green roof or the insulation we have to decide. In walls also, as we have seen in our vernacular architecture, the thickness of the wall is 1 meter. But nowadays we can't provide the 1 meter thickness or neither the stone as a material, but we have to develop the new techniques like double wall, or the rat trap bond is also very important to have minimize the solar radiations. This is, I'm talking only on hot dry. Now for the cold climates, it will be different techniques. And then the floor, what kind of floor we are giving. Then fenestration, I have already told that which kind of door and windows, the shape, the material, and the location and the ratio as per the space. And then what kind of external color you are using, what kind of texture you are using for that particular building, which will minimize the solar radiation entering into the building. Now, materials also plays a very important role in terms of embodied energy, because embodied energy of materials is basically the energy required to prepare that kind of material which are going into that building. So from where we are extracting the material, how we are manufacturing the material, and then how we are transporting that material to the site, that is important. So selection of appropriate materials that is with low embodied energy materials is very, very important. And as we have seen that concrete and steel concrete is having the highest energy, aluminum has the highest energy, embodied energy. Now, if we are we are selecting this low embodied energy material, we have to do we should go for eco audit. That is materials which can minimize the mass of part, then embodied energy, CO2 emissions, and then the virgin content is there or not. Nowadays, there are green building criteria in India, right? IGBC is there, Griha is there, then Assocham is has also developed this diamond rating system and other rating systems, in which they have given that what kind of materials we can use for the buildings and how can we manufacture by minimizing process energy or process CO2 per kg, then how can we transport. We should not waste energy in transporting the material from so distant, then use of that material, thermal losses, electrical losses, and disposal also. After the life cycle and of that building, we should decide that we should be able to, how can we dispose like toxic materials or materials that cannot be recycled, that we have to look into. Now I'll be just taking two examples, which are now, I think Government of India is also promoting these materials. And now we can, if we look at this picture, that this new Terminal T2 project, which spans around 2,55,000 square meter, and it is scheduled to be completed by March 2021. This is the International Airport of Bangalore. And we are using, they are using the material bamboo. And now it is very unfortunate that no Indian architect was selected for this project, because we are not working in bamboo. We are, though we are the second largest producer of bamboo in the world, but we are not using this material for construction. So that's why they have to hire an architect from US, and even the material is exported from Vietnam. Sorry, imported from Vietnam. So we have to look into this, because we are used to, in our curriculum also, there is nowhere bamboo is included as a building material. We are just teaching other materials. So we have to do something for this alternative materials, how we can promote this material in constructions. Otherwise, all these big projects will be given to Western architects. Now, if you can see, bamboo is used in the construction of roof, and why it is a very sustainable material, because it absorbs CO2 and it releases oxygen. So for climate change also, it is a very important material. And if we plant this material, we can use, and it is very fastly harvested material within 3-4 years. So it can be used in truss or roof. It can be used as a walls also. It can be used in flooring also. Scaffolding, so it's, we know that we use bamboo for scaffolding. It can be used in foundation also with some treatment and as a composite material. Now, if you can see the properties of bamboo over the other material, you can see the stiffness and density is also more, and the compression also in more in bamboo as compared to other materials. Even the thermal performance is good in bamboo. It has been tested by the researchers. And in Singapore, they are also promoting this material for a skyscraper. We can't think of bamboo skyscraper, but this is just a competition entry. And they are thinking, the simulations have been done about this bamboo skyscraper. It is, I think, 121 floor above and 6 floor down. So this is a competition winning entry. And bamboo, how bamboo can be used in as a composite material for skyscraper also, they are exploring. Now, the second material is biomass materials, types of biomaterials and their application. So there are different materials which are called as bio-based materials, which are created using plant aggregate and materials such as hemp, flax, and then mycelium, then wood waste, sunflower, corn cob, coconut, rice husk, timber, then bamboo particles may also be employed in the materials to yield the bio-based construction. So you can see in foreign countries, not nowhere in India. India, we have to explore. I think partition, I remember for hemp, we are making the internal partition boards. But in other countries, they have constructed the 10-story building, the timber staircase, the tabletops, then the mushroom tower, then again you can see the building, then hempcrete partitions, flagboards, the reeds, and bio-based bridges also are constructed. So we have to think of this alternative materials. Now, landscaping is also a very important parameter to conserve the energy. It is not only that after constructing building, the role of architect is over. We have to decide the landscaping part also, internal and external also. So what kind of trees we should plant so that we can improve in the microclimate of the site? So deciduous versus evergreen tree, then branch and twig density, which will have the winter sun filtration, then height, diameter, and form, then positioning for seasonal shadow, then arrangement of trees is also very important, by which we can improve the microclimate of a site, and thereby we will reduce the energy consumption in building. Now I will be talking about some case studies of India. So living laboratory, which is at CEPT, this is also zero energy building, then Indira Paryavaran, then Akshay Urja Bhavan, then Malankarati Plantation, Kottayam, Kerala, then this is a Gritco Bhubaneswar, Odisha, then Sun Carrier Omega, Bhopal, and eco-commercial buildings, wire material. These are some of the Indian examples I'm giving for zero energy buildings. And if you talk about the city, as we know in Masdar, I have seen this city. This Masdar city is one of the world's most sustainable urban communities and low carbon development, made up of clean tech clusters, then business free zone, then residential neighborhood with restaurants. And Masdar philosophy of urban development is based on the three pillars of sustainability, that is economic, social, and environmental. And this is a very good step towards the sustainable development of cities through application of real world solutions in energy and water efficiency. But only things which I think about this city, I have gone through this city, I have seen this city, affordability, poor cannot stay here. So that is the challenge, or you can say limitation here. So we have to address that also. It should be affordable to all. And this is also a living laboratory in New Dubai city. This is also comprising of low-lying villas and low-rise development, but they are using the solar panels in the complete city, renewables as a renewable energy source. Then in India, we have seen Chandigarh is as a solar city, and this is the only modern city, planned city in India. And we have seen that in many projects of Chandigarh city, they are using the solar panels at the rooftop, at the rooftop. Then, if we talk about the neighborhood at a neighborhood level, we should try to develop. Now a concept is there for vertical city also, and vertical eco skyscrapers also. So there is architect Ken Yang, who has developed this concept of vertical green urbanism, and he has come up with the eco skyscrapers. So how can we design the city vertically? So in that, he has addressed like placemaking, then linkages to the different parts of the cities, then vistas, the creating communities, then figure ground relationships, the spaces between the buildings, and how we can green in between the buildings. All the urban design concepts he has tried to address in this eco skyscrapers. We can see that he has designed also in Singapore and Malaysia. There are lots of examples of eco skyscrapers designed by Dr. Ken Yang. So first, understanding the site psychology, site-specific construction, then importance of orientation of building, the need for ecological design, configuring the built form and operational systems so that they integrate with nature, and orientation of the building, then solar sky courts he has introduced in this. And instead of conventional central cores, the building cores can be located on the exteriors, such as which are exposed to harsh suns to minimize the. Then integrating with nature. If we go vertical, it is always that there is no connection with the nature, or there is no connection with the ground. So he has developed this vertical gardens in the skyscrapers. You can see from the picture, these are the through vertical landscaping, he has achieved this integration of nature. Then recycling of waste. So all products and emissions need to be continuously recycled, reused within and reintegrated with the natural environments, and which helps determine the materials to be used for the building, materials to be used in the first place. So cradle to grave, we have to think about, and the management of this potential waste products, we have to think, and then retrofitting of older buildings is also better than the design and construction of new buildings. It is not about only new buildings. Now, if we think of the non-conventional resources, we have to think about this non-conventional resources while designing the cities and buildings like solar energy, wind energy, bioenergy, tidal energy, heat pump, and geothermal energy. And now I would like to summarize that this conference is about basically to achieve the sustainable development goals. So my presentation was based on energy efficiency or energy conscious architecture and planning, but all these goals are interlinked with each other. If we achieve energy efficiency in cities and buildings, automatically we will address the climate change issue also. Then we will address that is goal 13. Then we can address goal 11 also, sustainable cities and communities. And then if there are sustainable cities and communities, automatically the goal number 3 also will be achieved. That is good health and well-being, because outdoor air quality will be improved, indoor air quality will be improved, where we can spend our maximum time. So these all goals, we can see, they are interlinked, and then life on land also. So achieving this SDGs requires the partnership of governments, private sector, civil society, citizens alike, to make sure we leave a better planet for future generations. And how we can achieve that? We have to partner with the government also. Then we have to do the capacity building, then the collecting the data, then monitoring, then partnership based on the SDG goals, then the finance, then trade, and then technology. So I think the educational institution need to collaborate with the government institutions, and then whatever is needed for this, the research has to be in the universities, and there has to be a collaboration between government, then educational institution, and all the stakeholders. Then only we can achieve sustainable development goal in a better way. These are the references, and thank you for patient listening. I think.
Thank you, ma'am.
Yeah.
For your informative talk. We can take a few questions if we have. I do have a couple of questions. I think questions can also be put in the box. Is that right, Shweta?
Yes, sir.
Yeah, okay.
But
so,
no questions in the chat box.
Yes.
Yes, if there are any questions in the chat box. Before that, may I ask a couple of things?
Yes, sir.
Which I liked in your presentation. Since I am from Bangalore, I am liking the concept of bamboo being used for the new air terminal. So I look forward to see that new air terminal. But I just had a question. Will the bamboo have the strength bearing columns also will be of bamboos, or will they be using some other material in this?
Sir, it is of composite material.
It's a composite.
They are using with concrete also, because there are some examples of flyovers also are constructed in bamboo, but this is bamboo with concrete. So like composite material they are using.
Bamboo
but for interior, yes, we can use only bamboo.
Okay.
With the treated materials like fire resistance and all.
But
so there are
what about iron? Are they going to use iron also in this?
No. Instead iron, they are using bamboo and concrete. The reinforcement is of bamboo.
Okay, so they will completely avoid using the iron.
Yes, sir.
In the columns.
And composite also they can use.
Okay.
It is based on the structural load and
one more question was about the green building, particularly green vertical buildings. Since you are using plants in these mostly climbers and other things, I've seen a few buildings being made like this. But will it not increase the water consumption? Because to maintain these plants, you need a lot of water, right?
Yes, sir. We need a lot of water, but as against, there are pros and cons of each aspect. But by going vertical, there are debates also, because we are saving land as a resource, as a precious resource by going vertical. So there are pros and cons for each thing. So there are studies going on, like in Japan also, they are saying that sustainable cities means you have to go for a vertical city, compact city, so that we can save energy in transport or any other things which is required in the city. So there are pros and cons. So we have to do a research, and there are different systems for that.
Yeah, that's
like,
what I thought. One of the limitations will be the water consumption if we go for the green.
But sir, there are different materials also nowadays, like I think coke or something like that. With that also, the many plants comes. There is no need of like water. That is called,
which can absorb the humidity.
Yes,
from,
and that is called jerryscaping, which requires zero water.
Okay, okay, yeah. That will be a good alternative.
Yeah.
Professor Yadi.
Yes, sir. Ma'am, you talked about energy audit also.
Yes, sir.
Generally, whoever is the owner of the building wants to complete the construction within minimum cost and in minimum time.
Right.
So what are your comments on this with respect to the sustainability approaches?
Minimum cost and minimum time. Yes, I will like to give you one example, like solar energy, right? Initially, when it started that we have to use the solar energy on the rooftop or for electricity purpose, it is not cost effective. It is very costly. But if we calculate the life of that particular building, and whereas the electricity bills of that building, so it is a one-time cost. Like windowsill, if we are putting a kadappa, is a cost effective. But if we are putting a granite, is not a cost effective. So we have to see in a longer run. And then I think government is also promoting subsidies for this. And slowly, it will have it will take us to change the mindset of a people.
Okay.
Yes, I rightly said for the Masdar city also. It is not for the poor.
Yeah.
That I observed there. I have gone through the complete city. This very good energy efficiency. But what about the common people? So I think slowly, when the cost is like bamboo, I will say. For bamboo, now, if we have to construct in Rajasthan, we have to take bamboo from Assam or any other, because bamboo is not there in Rajasthan. So 10 rupees per pole or 20 rupees per pole to take bamboo in Rajasthan, many people are using for farm structures like polyhouse and all these things. So one cost of that one bamboo is 120 rupees. Okay. So instead, we can plant here whatever the suitable species is there, but for that there is no awareness because it is considered as poor man timber. Yes. We have started, we have included bamboo in our curriculum also, and now we are having one research project at our campus. We are planning to plant bamboo at the periphery of our campus, different species. And then we will see which species is better and for what purpose. In IS code, there are total 128 species of bamboo, but in IS code, 8 species of bamboo are suitable for construction.
Yadi sir, I may just add here that our agriculture institute has already planted bamboo in our campus for agroforestry regions. Wow. So you can use the bamboos now, right in the campus. Like Madam is telling, it is true that bamboos are now being propagated everywhere since they have many uses. Okay, can I quickly take a question from the question box?
Yes.
There is a question. What is the line city?
What is that?
Line city. L-I-N-E. Line city.
Line city?
I don't know. It is that.
I haven't heard of this.
Okay. Okay. Another question is this is from Mr. Abhijit. Can you guide us about the life cycle of a solar cell and how we can deal with its waste?
Life cycle of solar cell.
Yeah.
As an architect, I am not expert in this solar energy and also. Okay. Sorry.
Okay. This is a question for scientists, Mr. Abhijit, and we will answer it at some other point. Let me just take another question related to this topic. No, I think there are no more questions. Okay.
So there is one question. I think from Purnima Jairaj.
Yeah.
How does an social dimension contribute in addressing climate change?
Social dimensions. Okay. I think, yes, in architecture or city planning, we cannot design without people. And they are at the center. So we have to involve them. And for research also, we have seen, like in academic research, what are we doing here is like we are taking some topic, framing hypothesis, research questions. We are completing our research that goes into the library. So we have never given a thought, like in social sciences, it is there, not in engineering and other fields, because we have to promote this community-based participatory research. For anything like climate change also, we have to involve the people, and then only we can address the social issues for climate change.
I can see one more question. That is, why we take bamboo for climbing on the building? Can we choose some other thing? This is from Mr. Vivek Pomermar. But I don't see what is wrong in taking bamboo for climbing.
And it is lightweight.
Yeah.
Lightweight, it is available, it is cheaper, and it is fast for construction, like scaffolding also. It is very fast to tie that. That must be the reason. And it is good.
Okay, I think I wish to thank Madam for her very illuminating talk, and she has raised all of the interest of listeners, particularly in using alternative materials in architecture. Thank you, ma'am. Can we now have the next speaker, Professor Tripathi from JNU? Tripathi, sir, you're connected now?
Yeah.
Okay, please.
I'm presenting now. Okay, I say impact of climate change on biodiversity agriculture. When we talk about
So your slide was visible.
Well, visible, na?
Yeah.
Yeah. Then something happened that I could not move that slide. When I go into the next slide, na, I could not present that slide. Doesn't move, you know.
Yes, yes.
You see, it doesn't move this slide somehow. Something has happened. I don't know. Screen sharing.
So your cursor is visible. So hopefully.
I don't know. Yes, in Zoom has this problem. Always. The slides do not move sometimes.
Shadab sir, could you please guide?
Can you see the, sorry?
No, slides are not visible right now. Yes, now it's visible. Yes, it's moving now.
Yeah, yeah.
Okay.
Sometimes it moves. Yeah.
Yeah. Okay.
The most amazing and dangerous illusions we have. Humans, what is this illusion we have? Humans have solved other problems in the past history of the earth, and therefore they certainly can solve the ones that we shall face in future. So this is a thought process that yes, we have solved all our problems in the past, so we can also solve all our problems in future. Okay. this is an illusionary process. But the illusionary thought process does not take into account the magnitude of the problem we encounter even in our daily life. What we are in nutshell saying that we cannot be sure that we will be able to solve all the problems we face in the future. You see, we are consuming or wasting an estimated 55% of terrestrial net photosynthetic productivity and using about 65% of the fresh water today. And we know what fresh water is. Okay? And looking at the availability of fresh water, water table going down and down and down because of urbanization, lift irrigation and all that, we need to conserve fresh water. And the fresh water is slowly disappearing, going down and down and down. It may be extremely difficult to harvest fresh water after a few years, even for agriculture, for drinking. Okay. So nothing like this had existed before in our past history of mankind. We see if we want to survive together, we have to live in this sustainable world, build a sustainable world, to build a harmonious earth where human beings, animals, plants, and microorganisms will be able to continue to sustainably coexist harmoniously and peacefully in all the time to come will require Himalayan effort and immense scientific wisdom. And we don't have it. Okay? All of us are live together, not that human beings become dominant species and kills all animals, all plants, all microorganisms, and they disappear from Earth. And this is happening. They are disappearing from that because we have become human beings have become a dominant species, and therefore a lot of people are disappearing, a lot of species are disappearing. Okay? To feed the millions of people of the world during the last 70 years, we have lost about 1/3 of the topsoil and 1/3 of our agricultural land. Okay. What I have done here, of course, topsoil, and we have also lost 1/3 of our agricultural land for what purpose? For making buildings, human habitation, making factories, and so on and so forth, and so on and so forth. And also we have lost a lot of forest cover. Okay, so we have lost over 1/3 of the topsoil, and topsoil is extremely difficult to build. It takes years and years and years to build topsoil, and the topsoil goes as it goes, nothing will grow in future. And 1/3 of the topsoil is already gone. Okay, in the last 70 years, we have changed our atmospheric composition by increasing the greenhouse gas carbon dioxide by 50%. There is a 50% increase in carbon dioxide concentration in the atmosphere today than we had a few years ago. If you remember, when we were students, we were talking about we had 270 ppm carbon dioxide when we were studying in our classroom in our college, but today is 410 ppm. So 50% increase, more than 50% increase in the last 50-60 years. It is going to continue. This CO2 concentration is going to increase. As we are consuming more and more and more fossil fuel and cutting down the forest for our survival, for our expansionist activity. About half the forest that existed in 1955 are uprooted. You see, forests are very important for CO2 sequestration. They absorb carbon dioxide from photosynthesis from atmosphere. They convert carbon dioxide to carbohydrate at the expense of solar energy and store them in the tree trunks for years and years and years. Okay. Now, when you cut the forest, okay, all the trees are gone or burnt, or we put them in if we burn them or whatever we do, okay, then it creates havoc in the system. These plants will disappear. These plants cannot fix carbon dioxide anymore. So your CO2 concentration in the atmosphere is increasing. One of the reasons why we loss of forest cover and also contribute to global warming. If you go to any place, any forest area or a place, you will see that there will be, the temperature will be much lower than in big cities. That's because there are a lot of plants, and these plants give shade. Now they also transpire. Okay, so their leaves become cool in the process, and therefore, that area remains cooler. So, because I cut down the forest, the temperature is increasing. Also, CO2 concentration is not decreased because photosynthesis is reduced. So, the CO2 consumption is not increasing anymore. And besides, they are also burning fossil fuels. Okay, we'll come to that in a minute. So about half the forest that existed in 1955 were uprooted and converted to land for human habitation, or established industries or other anthropogenic expansionist activities. So the loss of forest cover has contributed to reduce rainfall, high carbon and high temperature world. When forest is reduced, forest cover is reduced, forest also transpires a process called transpiration, where water from the soil goes through the transparent surface of the leaves and and to the cloud, to the atmosphere, and that place becomes humid and it recruits cloud. That humidity recruits cloud. A lot of clouds come to the forest and make rain. And more forest we destroy, we are going more and more reduced rainfall. And at the same time, as I told you here, and high carbon world, because we cannot reduce carbon dioxide anymore. Okay, to carbohydrate and store them in tree trunk. So therefore, this good high carbon world and high temperature world. Okay, as I told you a few minutes ago, that tree cover is also gives us shade, gives us makes a cooling effect of transpiration, and that is not happening anymore. So you see, global warming also taking place due to that also. The human population pressure, coupled with increased trend of consumerism and undesirable non-sustainable consumption, are devastated fragile ecosystem. The increased the increased level extinction of species, now hundreds of times above the background rate, for the last 5 million years, would likely disappearance about two-thirds of kinds of living organisms by 2300. I'll come to this point later, so I'll come to the point later. What has happened? If you see, a lot of species are disappearing. Okay, we have, you see, if you look into biodiversity in our ancient times, okay, very, very ancient times, when we are not even there, okay, it is 500 millions of years ago, 500 millions of years ago, this is x-axis the time, y-axis the biodiversity. The biodiversity was minimal, and because 500 millions of years ago. But now the climate of the world changed. So climate is a major determinant of biodiversity. We'll talk about a few minutes. So the biodiversity increased because of climate change, situation changing, and you can see this is a big extinction event, a Cambrian extinction event. And this extinction event took place around 250 millions of years ago. A lot of species died, vertebrates died, many huge plants died, a lot of things died. Of course, there are no mammals those days. Okay. But then came reptiles, of course. And here came huge reptiles in Jurassic time after these big extinction events. And then the dinosaurs came here, and they also became bigger and bigger and bigger, and they also became extinct at certain time here. If you see, there are also Indian giants who have become extinct and all that. So if you see the process, okay, so now you can see this extinction event, this extinction events when dinosaurs disappeared, okay, and they disappeared due to huge extinction events that we know. But I'm telling you, if you compare this extinction event, as mostly geological reasons, maybe asteroid collided in the world, or the collided the earth, or something happened, so that all the dinosaurs died. Okay, so you can see, therefore, lot of species disappeared and dinosaurs. Thousands to thousands species disappeared. Remember, number of species that evolved right from the origin of Earth to today, we have lost more than 95% of the species. Okay, in the extinction events, only 5% of the species, less than 5% of the species, are surviving today. Okay, so 95% of species disappeared. Maybe blue-gill-like organisms survived, some bacteria survived, very small animals, plants survived, but most of the plants, most of the animals are dead, they are become extinct. Those species, you cannot see them anymore. And this has happened to be due to many other reasons, including geological events, over which you don't have any control, or also due to climatic change. So climate change has actually affected our biodiversity long, long way. Okay, and here, of course, happened geological events. Okay, so if you see this extinction event that took place, 65 million of years ago, and man-made extinction event that is going on today. Okay, this is man-made extinction event. We evolved only here, only 1 to 1.5 million of years ago here at this point. And when you evolve here, we have become such a dominant species in the world that we are destroying our biodiversity at least 100 times faster than the rate of extinction. You take the average extinction event that took place from here to here, and this is 60 million of years and now, okay, 69 million for now, you'll see that a lot of things are happening, okay. So, all right. So this is major extinction event. So what I want to say here, that when our ancestors then, you see, we evolved only 1 to 1.5 million of years ago. Then we are nomadic people. We are just moving place to place for food. Okay, we are living on nature. We're living in forest. Then what happened? We learned how to do agriculture around 10 to 15,000 of years ago, 15,000 years ago. So when you learn agriculture, okay, so you don't have to go for hunting for food. So you build civilization. The population started to increase, okay, and because people didn't die of hunger, human beings have now single-handedly. So our number have increased. Since the last 15,000 years from now, or I'll say 10,000 years from now, human beings have now single-handedly driven millions of species to the 6th great extinction event. Nearly 65% of land species are threatened with extinction. Think about that. Fortunately, we are not in water, okay, not in sea, but on land. So aquatic biodiversity is, more or less preserved. Of course, there are many other impacts that we are polluting the ocean, and global warming also impacting ocean, because man-made global warming also impacting ocean and affecting biodiversity. But we have not threatened so much the sea species, aquatic species, than terrestrial species where we live. Because we have nearly 65% land species that threatened extinction. 65% of land species. Think about that. because we are driving extinction event. If you see extinction events, I've told you, the increased level extinction species now hundreds of times faster above the background rate for the last 65 millions of years ago. If you see average extinction events for the last 65 millions of years, and extinction events today, the 7 species, at least is hundreds of times faster. But this is man-made extinction. And this extinction event is roughly connecting the events that took place toward the Cretaceous period. However, this time the extinction event is not driven by geological events, okay, but by only one dominant species called Homo sapiens with human beings, evolved only 1 to 1.5 million of years ago. We evolved 1 to 1.5 million years ago. We remained in harmony for a long, long time. And once we knew agriculture, then our population grew. We built civilization, and we fought. Of course, we fought. We fought with many people. Made greediness and all that developed in the civilization. That is a different issue. But at the same time, we drove the species to extinction, several species to extinction. When we try to become dominant species, yes, we can be dominant species, but still live in harmony with nature, which we are not doing. Man is active in driving mass massacre of living beings. They're taking place today. Okay, with a dependable supply of food from agriculture that could be stored, because now agriculture, we developed increasingly complex societies with it. We formed different states, went to war with one another for the interest of rulers in the name of religion, and exerted pressure on the ecosystem that the ecosystem could not endure, could not tolerate, because you think so much, we bring greedy society, we went to war, and so much war we have fought. Even today, you think of Second World War, think about world wars before, and so many wars are fought. Before, England and France fought for centuries, and all these have devastated ecosystem. War is one of the machines where also use a lot of biodiversity. We live in non-sustainable ecosystem, and we are constantly destroying it as we use up resources developed in skewed manner. So, we are developing resources. About 2 billion people of this world live in abject poverty today. Okay, about 2 billion people of the world. And out of them, out of 800 millions are malnourished today, to the extent of their brains do not develop properly. So when you are talking about climate change and all that, okay, we are talking about, big thing, that, malnourishment and all that. But at the same time, we're also seeing that a lot of people are dying today out of hunger. It is not that we are building a society, a compassionate society, or building a sustainable society, but also building a complex society. Okay? The rich nations with only 20% of the global population, okay, they're all rich nations, all developed world. They contain 20% of the global population. They have only 20% global nation. But control 80% world economy. They use their money power to destroy the environment. They have used all their money power to destroy the environment. Okay. They dominate or strive to dominate every ecosystem. Okay. Every ecosystem, man, land, even ocean will go. Anyway, they dominate or strive to dominate every ecosystem. Depositing manufactured chemicals into every square kilometer every day. They pollute the sea, pollute the land, everywhere. Pollute all ecosystems, whether pond or ocean or forest, they are polluted everywhere. Therefore, lot of biodiversity have disappeared from developed world. Okay, therefore, only 80% of people in the world who live in developing countries like us, and of course we And Africa, like us, Africa, about 80% of the world's biodiversity. Okay. All right. So 80% of the world biodiversity is present in developing world, developing country. But developed world have destroyed their ecosystem. They have only 20% biodiversity of world. Developing world does not have more than 20% of the world's scientists. Okay, the developing world. But we don't have, if you compare the number of world scientists, we have 20% world scientists. Most of the world's biodiversity is in developing countries like India. Okay, I'm just giving an example. But also they are also in Africa. However, we Indians are also now destroying our biological heritage. We are also now destroying biological heritage, cutting down forests, cutting down all ecosystems. Remember when you cut one tree, we just don't cut one tree. We cut a tree and destroy all the insects, taking shelter of the tree, okay, and so on and so forth. And when those insects are destroyed, the insects are used for pollination. So if the pollination, when the pollinators disappear, there are no pollination anymore. So insects are disappeared, no pollination. So they cannot set any seeds anymore. So the species, the plant also disappears. Okay. So remember, the insect world, plant world is also dependent on insect world also. Insect dependent, of course, on plants of the nectar, but plants also depend on the insects for pollination. There are several insect pollinators today. Thousands of plant species is pollinated by insects. Okay. But if the insects are gone, all species are pollination cannot take place. There is no fruit setting, no seed production, and our biodiversity will disappear. Okay. Our biodiversity is being lost before we even begin to understand the unique potential and uses. They are disappearing. We are the man-made extinction events. There are two extinction. One geological extinction events I talked about, and man-made extinction events. The man-made extinction events I told you is now hundreds of times faster than geological extinction events. Okay, so when that these man-made extinction events, is being lost. When our biodiversity is lost, when you understand the unique potential and their uses. Okay, we don't know before to understand what species can do for us, what use we can take out of it is gone, extinct. Okay, we have not studied it also. Remember, we have only identified few species, few percentage of species of the world, not whole species. Around 90% of the species we have not identified in this world. Only 10% of species we have identified so far. Now we dominate every ecosystem on Earth and must manage the sustainably for a future generation. We can dominate in the ecosystem. We don't have to dominate them, we can live sustainably. Okay, and use it conservatively for our future generation. Okay, our biosphere reserves and national parks need to be managed better. We have biosphere. Okay, the spirit of Rio de Janeiro Art Summit 1982 should be followed in true spirit. Okay, developmental goals and preservation of biodiversity must go hand in hand. That's important. We have developmental goals, but also we have to preserve biodiversity. And this developmental goal and preservation of biodiversity must go hand in hand. Okay, we just cannot have all development and when our biodiversity is lost. We cannot just cut down forests so that we can make a factory there. Okay, and this must not happen. Presently, whole genome sequence are routine done for several organisms. Now we know the difference and similarities and dissimilarities of rice and human genome. By genomic data, we can establish evolution relationship and probable origin and genetic similarity and diversity about different kinds of unrelated species. We have all the genomic data today. So we can analyze and understand what is the evolutionary relationship we have. We need to understand and realize the useful potential of incredible biodiversity that thrives in the earth. What is the potential is? What is the potential of biodiversity? We do have, before even we don't even know what is species. You hardly know very few potential. There are so many species, and so many species not even identified. Okay, so before we have to preserve those and at least look at those species, what they are, what can they do for us, what they let them survive in the nature good spirit, but whether we can get a benefit, we as a human being can get a benefit out of them, either as a medicinal plant or something else. Okay, we just talk about how bamboos can, develop our society today. Okay, in this context, the impending probable extinction of thousands of species in the present century is unacceptable. We have identified less than 25% total species that exist on Earth. Less than 25% species identified. Some people say 10% species identified. Okay, whatever it is. But that is a matter of debate. But at least 75% species are not identified. Okay. So we don't know what species are. We have not classified them, we have not identified them. So they are gone. So this is gone forever. So you have to make bigger effort to understand their potential, to find out species, identify species. Then only our human race can progress further. Our knowledge of biodiversity and Earth is complete. It is highly inadequate for challenging to face the world. As I told you, our scientific investment is very low. Largest investors in the scientific research is USA, followed by China, Japan and Korea, Germany, UK and France. We are nowhere. Scientific investment in India is less than 20% of China. Okay. All right. So how much China spends 5 times more money on scientific research. Therefore, we are neither in a position to enumerate, catalog, and determine the possible uses of biodiversity. Okay. We are not positioned even we don't want to spend money to understand our biodiversity and its use of biodiversity for us, for our sustainable economic development. Okay. We have to at least triple our scientific spending to cope with challenges we are facing to develop a sustainable world. Millions of scientists, both social and natural, are unemployed today. Okay. Both social scientists and natural scientists, millions of scientists in our country are unemployed or underemployed. With the minimal scientific investment for millions of people, we have very minimal scientific investment today. When you take 1 million people, our scientific investment will be very, very minimal. Maybe look smaller than Bangladesh. Okay. Cannot employ our graduates to do meaningful research for social advancement. So important, we must spend money on education, we must spend money on agriculture, we must spend money on scientific research. It's very important. Then only probably our society can progress further. When you talk about biodiversity, let us talk about what triggers biodiversity. Greenhouse Earth, it triggers biodiversity. Oxymetabolism photosynthesis, it has triggered biodiversity. I'll talk to you in a moment. Competition selection forces, evolution, that also always triggers biodiversity and all could be negatively related to biodiversity. Increase and decrease of niches and permissive ecology and extinction events. They're all contribute to biodiversity. If you see, I was talking about climate change, and climate change has, of course, impacted biodiversity. Let us talk about climate change right from the origin of Earth to today and see how it has impacted our biodiversity. Okay? If you see, around 4.5 to 4.6 billion of years ago, billions years. 1 billion is 1,000 million years. So at 4.56 billions of years ago, Earth came, Earth, or this origin of Earth. And this is today's world. Today's Earth is 0, and it's all going back to 4.5 billion years ago. And what is it? Carbon dioxide. You see green colored carbon dioxide. Carbon dioxide concentration is very high when Earth was born. And today, actually, Earth CO2 concentration is minimal. Okay. And it is going up. When you say we're going up, we can see this increase you're talking about CO2 increasing. Okay. Climate change, CO2 concentration increasing. Okay. This small increase going up. This was referring to increasing CO2. Okay. And what about oxygen? It is completely unoxygenic world. There's no oxygen. Okay. But here came life forms 3 to 3.5 billions of years ago came life. And cyanobacteria probably came even 3 billions of years ago. And there's no oxygen. Then at this point, they are full of archaea. Okay. The anaerobic world. Okay. There's no oxygen. So anaerobic life thrived. Archaea survived. A lot of non-photosynthetic bacteria came and survived. Earth is full of life, but anaerobic life. Okay. Paleolite. And they didn't have oxygen because they didn't have oxygen. But the life evolved on water also. Water was everywhere. And in anaerobic life, photosynthesis, it's slightly not much technical. There could be hydrogen sulfide, okay, S2S. There can be many other chemicals which could become an electron donor to reduce carbon dioxide, carbohydrate. Today we have photosynthesis, where water plus carbon dioxide combined to form carbohydrate and oxygen. But here, when there is no oxygen in an anaerobic world, okay, so water was not the electron donor. That the hydrogen sulfide or similar compounds was the electron donor. So S2S plus CO2 form carbohydrate and sulfur. Okay. So instead of evolving oxygen, they're evolving sulfur. Okay. Or something else. Okay. So, and they did not evolve oxygen. So this photosynthesis, therefore, this anaerobic photosynthesis. Okay. But there came cyanobacteria, or so-called blue green algae. And this blue green algae, cyanobacteria, they evolved chlorophyll A. Instead of bacteria chlorophyll A, they had chlorophyll A. And this chlorophyll A could absorb at wavelength of 660 nanometer. And as I told you, as you know, this energy was sufficient to make water to oxygen. Okay. So they broke water to oxygen. So what they did, they reacted with CO2, reacted with water to give carbohydrate and oxygen. So when CO2, when Earth is full of water, life was in the ocean, and when water was oxidized, you see, there and by the process of photosynthesis, you can see so much oxygen came up in the atmosphere. So a lot of oxygen today in the atmosphere, mostly because started by photosynthetic bacteria, oxygenic photosynthetic bacteria like cyanobacteria. Then, of course, evolution came, then came algae, and a lot of algae generated in ocean, aerobic algae, and they photosynthesized and and fixed carbon dioxide, and then oxygen content in the atmosphere went up. And when oxygen content in the atmosphere went up, CO2 was consumed from carbohydrates. Of course, CO2 got cycled back, but a lot of CO2 was consumed. Okay, some of them, became petrol and coal and so on and so forth, and CO2 concentration went down. And then there's an increase in CO2 around 300 millions of years ago, or 200 millions of years ago. And that is mostly due to volcanic eruptions, geological events. CO2 concentration in the atmosphere again went up because of volcanic events, and then again came down because of photosynthesis. And if you see, this is around 50 millions of years ago. 50 millions of years ago, CO2 concentration became very, very low. At that point, if you see, if you see, CO2 concentration, was very high here, but there's no oxygen here. So water was oxidized to form oxygen, carbon dioxide and oxygen. Okay. So when oxygen concentration in atmosphere went up, okay, it started competing with an enzyme called Rubisco. Well, Rubisco evolved in anaerobic world. Ribulose bisphosphate carboxylase oxygenase, but it evolved in anaerobic world and it functions only as ribulose bisphosphate carboxylase. If you do not know what a Ribisco is, I'll explain it a little later. Okay, I will come back to that later on. But as I'm saying you, as oxygen concentration in atmosphere increased, Rubisco oxygen started competing outside Rubisco, therefore photosynthesis rate declined. Therefore, when the C4 plants, when CO2 concentration became very low, okay, C4 plants evolved here. Okay, at 50 million years ago. And we talk about this increase mostly today, and this is mostly because anthropogenic events, man-made interaction with nature. I told you that oxygen concentration went up, and and what are methane? Of course, methane was there. There are also methane-producing bacteria like methanogenic bacteria, archaea, and all that. Methanogenic produce a lot of methane. Also, methane was here due to many geological reasons. But then you can see one aerobic life went, anaerobic life disappeared, and aerobic life went up. It's a lot of aerobic life disappeared. Okay, and anaerobic life disappeared, and aerobic life went up. And as you can see here, therefore, when anaerobic life disappeared, okay, almost, you can see here the methane concentration have substantially gone down. And we can see the anaerobic life probably in rice fields, anaerobic bacteria who that live in waterlogged conditions, okay, and also in dump yards and all that, you can see a lot of anaerobic life, and they're producing some methane. But as I must tell you that their concentration, their amounts have gone down, their numbers have gone down. Many of the anaerobic species have become extinct. That's happened because there is climate change. Okay. So when you think of this species evolved in anaerobic world have become extinct today, lots of them become extinct in aerobic world. So and the aerobic species were not absent here and have come up here. So you can see how the climate change, atmospheric climate change, have actually, formed, life species, life species.
But sir, we'll have to move a little quickly.
Okay. And if you see the oxygen concentration, as I told you, gone up, okay? The oxygen concentration is 2 billion of years ago. The oxygen concentration gone up and is coming up and up and more and more. And photosynthesis starts here. Then 3 molecules of oxygen to combine to form 2 molecule ozone. The ozone layer develops, and the ozone layer develops. You can see that they prevent the penetration of UV light to the atmosphere, to the earth. Therefore, the evolution process became faster. Okay. The DNA damage that taking place here due to UV light was reduced. So you can see the evolution became faster. Then, of course, prokaryotes and eukaryotes develop. Then sexual reproduction starts. Then animals develop skeleton, vertebrates came. And long after all this life has going place in the ocean, and then you can say about 400 millions of years ago came land plants. And 350 millions of years ago, then came land animals. Then came, of course, the dinosaurs, reptiles, dinosaurs. You see, dinosaurs came to this world when oxygen concentration in the atmosphere was around 17%. So the dinosaurs are huge animals. They have huge lungs capacity. They need a lot of oxygen. So therefore, their evolution had to wait. Their evolution had to wait. Till the atmospheric concentration in the atmosphere became 18%. Here the oxygen concentration going up and up and up in the scale, and they evolved when dinosaurs came, when oxygen concentration in the atmosphere was 18%. So what I want to say, and then come for extinction of dinosaur took place here. Then of course we as human beings only evolved here. Then came mammals, and we evolved somewhere here, but 1 million of years ago here at this point. Okay, so our origin is extreme, very, 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 very recent compared to all the organisms we saw. I talked about it. So a lot of them have come and gone because of geological reasons, because of climate change. You can see climate change can impact, as I told you, 95% species have disappeared from this world because of climate change, because of geological events, okay? But this disappear and oxygen has become major determinants of evolution. And this oxygen is the photosynthetic oxygen that developed in the world. So you have preserve our plant kingdom, okay? If we are talking about, if we want to preserve ourselves, okay, we cannot survive if we do not preserve our plant kingdom. Okay, and of course I will not talk about this much, but I must talk about it a little bit to you. This is a slide here. We're talking about climate change, and this is again going back to the past of a geological time. This is the Silurian time. This is where land plants came, okay? Some pteridophytes were there, bryophytes occurred here, vascular plants came, rhinia and all that, if you remember, okay, whatever. Then of course came tree forms in Carboniferous era, around 250 million years ago. And this is a cooling phase. This was the cooling phase. You see, this is the dotted line. Anything left to dotted line, the warming phase, cooling phase. Anything right to the dotted line is the cooling phase. So you can say Carboniferous cooling is white here. Carboniferous is cooling phase, okay? And then all other period was the warming phase. And now today actually, geologically, we are in cooling phase. So we are actually in ice house. We are in cooling phase. Okay? It is happened due to geological effects. We have not done it. Okay? Because geological regions, this is a cooling period now. Okay? Because it depends upon the sun, Earth's rotation, Earth's cooling, and all that. You can see, and after millions of years, cooling phase was in Carboniferous era and Permian era, and then our Triassic, Jurassic, where dinosaurs came, all those people, they're all warming phase. Now only we are in cooling phase. Okay, and therefore, and what they are doing now, this is a cooling phase, that is geological event. And we evolved only cooling phase. We evolved here only, okay, in this era, okay? In this period when the Earth was cool. We could not evolve before. This one condition did not evolve us. Think about it. If we evolve in this cooling phase, okay, and what is happening now, see, in this Carboniferous era, it has cooling phase. And this is the era actually where life was blooming, okay? Where lots of plant species and animal species evolved, okay, life evolved, and a lot of photosynthesis took place in this Carboniferous era, mostly tree forms and later Permian by gymnosperms, okay, and they did so much photosynthesis those days, okay. The Earth is full of those there's a lot of carbon dioxide in the atmosphere. And there's not oxygen much in atmosphere, less oxygen in atmosphere. They're doing all photosynthesis, no photorespiration. They fix a lot of carbohydrates. And those carbohydrates became fossils, okay, and they became coal and petroleum. So they remain fossils, become coal and petroleum, and on. What we are doing, those carbon dioxide, they were fixed millions and millions of years ago. We are now extracting them from the earth and burning them to put the carbon dioxide up into it. Okay. Therefore, we are shifting slowly again to warming. And happening, okay, we use CO2, IPCC prediction says that CO2 concentration may increase 700 ppm by end of the century. If not 600 ppm, 700 ppm, 600 ppm for sure, or maybe 650 ppm. For the temperature, because of global warming, temperature may rise by 3 to 4 degrees centigrade. Okay. Yes, global warming is taking place. Global warming has taken place. Of course, this ice cover decreasing, icebergs in the ocean are splitting. This is glaciers are melting, polar bear is out because of melting. And okay, I'll not skip this, I'll not talk about this. Yeah, okay, this is a complex, I'll not talk about. I'm talking about chlorophylls here. This is bacteria chlorophyll, this is chlorophyll D, this is chlorophyll A containing organism. So bacteria chlorophyll that came in anaerobic world could absorb 780 nanometer. So it has not enough energy to photosynthesize. In the process of evolution, the wavelength of the chlorophyll has shifted from longer wavelength to shorter wavelength. Today's chlorophyll A is 663 nanometer, and later on came chlorophyll B, much after that, much after chlorophyll A, which absorbs 645 nanometers. So these had enough energy. These had enough energy to split water to oxygen. But bacterial chlorophyll A did not have enough energy because longer wavelength. So energy of the photon is CH by lambda, longer the wavelength, less is the energy. Okay. All right. So I'll not talk about this here, but I just told you the CO2 concentration has been increasing. The CO2 concentration, we did an experiment in the field, so that you can see the CO2 concentration. We are pumping the CO2 from this drum, from the CO2 supply. The CO2 concentration inside ring is increasing. This is called pre-air carbon enrichment facility, which we developed in JNU. So you can see the plants growing inside this field have a lot of CO2, around 60 ppm CO2, whereas here ambient CO2 are 400 ppm CO2. And if you compare these plants here, we saw these plants are bigger. I will not talk about big photosynthesis here, but I'll show the plants they look like. These plants grow in ambient conditions, present 400 ppm carbon dioxide, and plants grown in the field in 585 ppm carbon dioxide. You can see plants have become taller, they have more leaves, they have more biomass. You see here, the plants become plants here, the plants have more leaves, plants have more biomass, okay? And there's another variety of brassica, they are also different kind. You can clear-cut difference in morphology, how much leaves they have, how the biomass they have, and of course, they have more yield also. Okay. Yeah, they could become more photosynthetic, they convert it to zinc, and I'll not talk about much, of course, then evolution C4 plants, but when C4, I must take one point here. The C4 plants, if you take C3 plants at high temperature, 35, not very high, at 35 degrees centigrade, you get photosynthesis here of C3 plant, but a C4 plant photosynthesis goes on and on and on, even 35 degrees centigrade. This is morning to noon, morning to full sun. At noon, you can see photosynthesis rate goes up and up, and and you can see photosynthesis rate of this C3 plant is here, gone down already. Okay. That tells you that C4 plant can work better at higher temperature and could utilize solar energy better. So we could think of future crop also as C4 plants in the high temperature world. Okay, C4 plants probably will be going to let us able to survive. So we should think of improving maize and millets, pennisetum and all that. That will go into a future crop and to try to improve them. Okay, with these words, I stop here, but just last slide I will show you my conclusions here. How to combat elevated CO2, reduction in greenhouse gas emission, increase CO2 fixation of plants, especially reforestation program, which will must do the forestation now, plantation of fast-growing trees like Populus deltoides or any other fast-growing trees which can sequester carbon dioxide but survive for years. plantation of tree species and mangrove vegetation in the sea coast for carbon sequestration and conservation of soil. Generation of clean fuel biohydrogen using algae at the expense of solar energy. So we can produce hydrogen from algae for purpose of photosynthesis. For instead of fixing carbon dioxide carbohydrate, we will produce hydrogen from them, and we put biohydrogen in hydrogen produced by algae in fire. The hydrogen and oxygen combined to form water, not carbon dioxide. It is the most cleanest fuel, and that produced from solar energy. And also devising efficient solar cells for conservation of solar energy, conversion of solar energy to electricity. These are the few things you can think of to do to save our nature, to save mankind, and reduce the extinction events that are causing to other species of the world. Thank you very much.
Thank you, Professor Tripathi, for a very extensive lecture, particularly tracing the atmospheric changes over the eras and then where we are at present. And he has also suggested some solutions for mitigating the rise in temperature. If there are any questions, I am just checking it. I don't see any question. Dr. Shweta, do you see any questions in the chat box?
No, sir.
No questions in the chat box. So I just asked one question to Professor Tripathi. So where is this biohydrogen research is at present?
Okay, most of the biohydrogen research that is going on is in USA and Europe. Okay. We don't, in India, we don't have much of biohydrogen research. I did a small research in my own lab in own making, not because of I got a grant, but I made up his own. You can see I was producing biohydrogen from Canada Monash at energy.
Yeah, I remember that you were working on this. Yeah.
Yeah, you can collect hydrogen by downward displacement of water from algae. Okay, it's a biohydrogen collected here. Okay, this hydrogen collecting from algae. And this happens, when what happens here, the water is splits in photosystem 2 to protons and oxygen, and the electron travels here, and there is reduction. But the reduced reduction could give NADPH from carbon dioxide. But this reduced reduction can also give electron higher hydrogenase to these two protons that here generated here to form hydrogen. The electrons will migrate to electron transport chain, and hydrogen these protons will just migrate here to outside, coming from to the luminum thalocarbon ATPH. And once comes out, then these protons and electrons coming from electron transport chain to production can produce hydrogen. Okay, this hydrogenase enzyme. It happens. This Chlamydomonas can do it, but the hydrogenase is insensitive to oxygen. That's a major problem. Okay, and water therefore it is possible that you can produce hydrogen. Even many blue-green algae, they have nitrogen. Okay, nitrogen is also very sensitive to oxygen, but they are double heterocysts where they have lack photosystem 2, and they have no oxygen almost, and thick walls, and they can produce nitrogen. Nitrogen is good active, and through nitrogen is also we can reverse action. We can produce hydrogen also. So by blue-green algae through also nitrogen is reaction can also produce hydrogen, and hydrogen also can produce hydrogen. But these two enzymes are sensitive to oxygen. We can also do that, there are many other ways and means how to create anaerobiosity, okay, in the aerobic world, and also could produce biohydrogen.
Okay, thank you, Professor Tripathi, for your informative lecture.
There is a
Yes, Dr. Shweta.
Yes, so there is a question from Dr. Suren Prakash Gupta.
Yes.
That can we design some artificial biological systems to trap atmospheric CO2?
Yeah, artificial biological system or artificial system.
Can you read the question again?
Right. So the question is, can we design artificial biological systems to trap atmospheric carbon dioxide?
Okay, artificial mimic biological system. Yeah.
Artificial biological system.
Yeah, but to mimic biological system is talking about. Yeah.
Yeah.
Yes, there are many ways when we are talking about artificial hydrogen, artificial photosynthesis. Okay, where instead of doing in plants, we do in in test tubes. Okay, adding different chemicals and all that, and produce electricity, produce hydrogen. That also possible. So, and also sequester carbon dioxide. Yes, as I can reduce carbon dioxide concentration in the world. Also, you can reduce CO2 concentration in the world, of course, by many other means. Okay, many chemical means that is known, and also what we are doing, trapping carbon dioxide and putting them to deep vent on Earth crust. That is happening. But the chemical means, biological means, I'm saying there are many biological, mimicking biological events and trying to do artificial photosynthesis to fix carbon dioxide to carbohydrate. And this effort is also on. It is only 5% efficient. Okay, and if you take efficiency of the plants 100%, then efficiency of the artificial photosynthesis is now 5%. Okay, but the progress is on, and we're sure that time will come. Probably we can do artificial photosynthesis to make as efficient as 100% of plants. Maybe if we can do a 50% efficient photosynthesis in artificially, then also it will be a great event. But how much sustainable it will be, harmony with nature, that will be debatable. It may not be harmony with nature.
Thank you, Professor Tripathi. I think we can now go to the next speaker. I invite Dr. Yatindra Singh Sodhya for his presentation.
Good morning, and thank you for having me in this Sanmantrana 2021, which is on sustainable development goal. And after having listened to two very important speakers, one an architect and another plant scientist, I'm from the different background, which is of social science. And I'll be talking in terms of sustainable development goals, rural development and grassroots governance issues and concerns. Honorable Chair of the plenary session, Professor Guru Prasad, Professor Vishal Yarti, my co-panelist, Professor Tripathi, Professor Madhura Yadav, Honorable Vice Chancellor of the University and convener of this Congress. When I'm talking in terms of the sustainable development goal, in terms of rural development, because whenever we are talking in terms of development, in Indian context, you cannot think of development without thinking of rural development. And what is precisely the rural development? Rural development is something which is talking in terms of the quality of life of the rural people. And again, when we are talking about the rural people, the most marginalized and vulnerable poor section of the society living in the countryside, and if their want and need are addressed, then that is precisely the rural development. There are three very important aspects of rural development: poverty, unemployment, and inequality. If we are able to address these three, then we are dealing with the rural development. And basic element of rural development are again three: the basic necessities of life, the self-respect and freedom. We are by and large talking in terms of basic necessities of life even as of today. and we have to make move from here to self-respect and freedom. And unless these three happens, we cannot think of rural development in its totality. And that is the reason why when 2/3 of the population living in the countryside, 70+% population is in rural area, and that is the reason why the rural development was, is, and will remain the focal point of the sustainable development goal. And if we look into the main objective of rural development, what precisely we mean in terms of rural development, we are talking in terms of the economic, social, political, and cultural development, and the basic on which the whole idea of development is premised, which is on life sustaining goods like the services, food, clothes, shelter, health, and security. These are the 5 things on which we have to work so that we can bring the marginal section of the society into the mainstream of the society. And if that happens, then rural development is likely to take place. And again, the very important aspect is to increase the purchasing power. Per capita income is to be enhanced through the different welfare measures so that we can provide better education, productive and remunerative jobs, and cultural amenities to the masses. And again, very important aspect of this particular dimension of rural development is to freeing them from the servitude and dependence. This is one of the very, very important aspect of the development phenomena. If that happens, then the change will start taking place. And against this premise, if you look at the sustainable development goal, as Professor Madhura in her presentation made a passing reference to it, that there are 17 goals. And when I was thinking in terms of rural development, then out of the 17 goals, 10 goals are directly dealing with the rural development. So if we have to achieve the sustainable development goal by 2030, we have to work hard in terms of rural development. And then only we will be able to achieve the SDGs by 2030. And what are all these goals are telling? Majorly, they are talking in terms of water, sanitation, housing, no poverty, energy, health, environment, education, employment. And all these things are to take place at the village level, and then cumulatively, if it happens, then at the state level and at the nation as a whole, we will be able to address the sustainable development goal. And if you look at the flagship schemes of the government, Swachh Bharat Abhiyan or Make in India, Digital India, Skill India, Jan Dhan Yojana, all these are the core of the SDGs. Government is trying its level best to address the SDGs through all these flagship schemes. And against this backdrop, there is a very important aspect in terms of planning, and that is known as Gram Panchayat Development Plan, GPDP. And GPDP is basically to address the issues of sustainable development goal. And these sustainable development goals, if we look in terms of the local government, then the first sustainable development goal is talking in terms of poverty-free villages. The sustainable development goal 2 is talking in terms of hunger-free village. And we are again listening every now and then about the malnutrition and hunger and all these things. And then we are talking in terms of sustainable development goal 3 is talking about the healthy village. And we have observed the pandemic, we have seen the public health system of the country as a whole, and how this particular aspect is so very important. We have seen in the new budget that there is a very huge increase in the health infrastructure, keeping in view the kind of pandemic we have faced recently. And if you look at the goal 4, that is talking about the education for all. And this education for all is not just access to education. It is again talking about the quality, lifelong learning opportunity. And goal 5 is talking about the gender and gendering the development. Development has to happen for both men and women. And we are talking about the goal 6 about the ensuring and availability of the sustainable management of water and sanitation. The water and sanitation is big issue for the country like India, wherein we have Swachh Bharat and Swachh Village schemes are put in place. Then energy is again a very big talk for all of us, and affordable, reliable and sustainable modern energy is the need of the hour, and goal 7 is specifically talking about all these things. And goal 8 is talking about the local economic development, wherein we have to provide the employment opportunities at the grassroots level. Goal 13 is again talking, and Professor just before me was talking about climate change, and the climate resilient towards the climate resilient panchayat is the goal 13, which is again coming in the rural development sector. And last but not least is about the restoring our ecosystem, again, which was referred by my previous speaker. And if you look at these 10 sustainable development goals, these 10 sustainable goals are directly related to the rural development. And if all these things are actually has to happen, then there has to be a hand holding between the GPDP and the SDGs, which I will be talking a little later. But where are we as of today? If we talk about the basic infrastructure in rural India, we are still lacking in terms of the infrastructure, be it education, healthcare facility. I'm talking about only the primary healthcare centers. Forget about the big hospitals at the village level or even small town level. The means of transport and communication, drinking water facilities, we are still not able to make available the potable drinking water to the countryside as a whole. We have traveled a lot over a period of time, but still the final destination is yet to be achieved. If we talk in terms of the electricity, both for domestic and agriculture purposes, still we have to make a progress so as to bring the rural infrastructure at par with the urban areas or any developed country. And against that backdrop, we have different policies, but it appears as if there is a need to have a rural development policy. And this rural development policy should be a comprehensive one dealing with all the sub-policies within the ambit of rural development policies, wherein the agricultural issues, poverty issues, rural enterprise issues, infrastructural issues are to be taken into consideration, and then we can have the holistic and comprehensive plan which can really deal with the sustainable development goal. And there are 3 very important areas wherein rural development has always been of focus. The issues are equity and growth oriented programs, the poverty and unemployment alleviation program, then natural resource and infrastructure development program. These are the 3 areas wherein there has been a consistent effort from the government since the first 5-year plan, 1951-52. And thereafter again, there has been a very specific focus has remained on all these 3 areas, wherein still we are talking in terms of policy and unemployment. So after even passing of 71 plus years of plan development, we have to travel a lot. And if you look at this particular map, this map is of Human Development Index 2018. And this map is saying what? The darkest green are the states where the Human Development Index is the best. Thereafter, the lighter green and the lightest green, and thereafter the light yellow and the dark yellow is the lowest Human Development Index states. Which are these states? These states are Uttar Pradesh, Bihar, and Jharkhand. When remaining Hindi heartland are in the lighter yellow. So the journey has to start from dark yellow, need to be converted into lighter yellow to lighter green to middle green, and middle green to darker green. If this particular cyclic process takes place, because most of the issues which we are talking in terms of Human Development Index are by and large dealing with the sustainable development goal, be it health, education, infrastructure, life expectancy, social capital. All the issues are directly related to the sustainable development goal. And if all these things has to happen, then we have to work hard to bring this dark yellow and light yellow to green and green to darker green. And this is a very important statistics which I am saying. I am running hurriedly because I have to keep in view the time which available with me. There are 3 bars, and what these 3 bars are telling? These are telling about the rural statistics in terms of the socio-economic caste census which took place in 2011. And if you look at the first bar, which is saying that 74.49% of the households have below monthly income rupees 5,000. Again, the second bar is saying that 56% of the household have no land, and 51.14% of the households are engaged into manual casual labor. These 3 bars are significant indicators of the ladder of development which we have. And we have to bring the sustainable development goal. We need to improve the Human Development Index, and we need to reduce these 3 bars. Unless we reduce these 3 bars, the development which we are envisioning will not occur. And this is very important and fascinating graph which is telling the kind of composition we have in terms of the gross domestic product, the GDP. And if you look at the 1950-51 bar, which is saying that the agricultural contribution was 51.88%, and which has gone down to 2013 to 13.94%. And if you look at the service sector, which was 29.5%, has risen to 59.93%. And what does it mean? It means that still a sizable population of the rural India is depending on agriculture, whereas the income or the contribution coming from the agriculture has gone drastically down. And in such a situation, we need to have a kind of diversification in the rural area so that we can bring better life and livelihood opportunity through the service sector in the countryside. This is what precisely is coming out through this map. I'm not going into the details of literacy status. Again, this is a big indicator which is showing that wherever there is a low literacy, the development is relatively low. And if we have to come, we have to bring the development better and faster. We need to improve the literacy rate, and not only literacy rate, we have to bring the better educational environment in these states so that we can have better skilled and professional education as well simultaneously. And when I'm talking about the sustainable development goal, I'm talking about the rural development. Both the things can only happen when we have a proper decentralization at the grassroots level, because that is the political institution available at the grassroots level which will be able to address both these important aspects. And if you look at the last decade of 20th century, there are 2 very important events happened. One was decentralization and another was LPG, liberalization, privatization, globalization. Both are contradictory to each other. But the decentralization has enormous potential. And there is a very important writing. One of the writing was from James Manor, who has written in a very important piece that there are almost 60 countries which have introduced decentralization in one form or the other. But the Indian case is a classical case wherein it has gone to the farthest. So keeping that in view, we have started the process of decentralization in the countryside in the year 1994. And now we are talking about all this development in 2021. So in the last 25 years, there has been a journey of decentralization. This decentralization, I'm not talking about all the details of decentralization, how it has happened, and what this decentralization is bringing to us. It is bringing the 11th schedule, which is talking about the 29 subjects, and all these 29 subjects are dealing with the rural areas which are directly related to sustainable development goal. And another very important, it has a mandatory representation of the people through the Gram Sabha. And this is a classic voters are part of Gram Sabha. The representation has been given to the marginalized section of the society, particularly scheduled caste, scheduled tribe, and OBC. And it has gone even further to give mandatory representation to the women at the grassroots level and even in the urban side. And there are two provisions of State Planning Commission and State Finance Commission, which are again directly making a devolution of three things: funds, functions, and functionaries at the grassroots level, so that they can directly engage with the rural development processes and bring in the sustainable development goal. These are the 29 subjects listed in the 11th schedule, and talking about almost everything which we were talking in the 10 designated sustainable development goals, which are bestowed upon the local political institution to deal at the grassroots level. And I'm not going into the detail. There are 3 million plus representation through the political process. Half of them are from the women category. 18 states have already given women representation. And the first and foremost thing is GPDP, which I was referring to time and again. Where from the GPDP will initiate? The GPDP will initiate at the Gram Sabha level. And this Gram Sabha is a body of all the villagers. They will sit together. They will think of the village in a holistic, comprehensive, and sustainable manner, so that the village plan they are bringing in can be of significant use for the village, for the district, for the state, and for the nation as a whole. And it should be holistic, it should be comprehensive, it should have perspective thinking in terms of the village. But unfortunately, if you look at the 25 years story, the Gram Sabha are not yet broad-based, not yet strengthened. There is a reluctance from the local bureaucracy and local political leadership that it has not yet come into the fore the way it should have been. But again, the representation of the marginalized section of the society has tried to bring a kind of social justice at the village level. The decision making has become a little broad-based. The vulnerable section of the society have come into the main talk of the development. Otherwise, they were completely eliminated or cornered in the whole process of development. And women, which is a significant part of the whole grassroots democratic process, has brought us very, very rewarding kind of examples before us. The development which has taken place, wherein particularly the health, education, livelihoods, alcohol, abandoning, or social issues have been very effectively dealt by the women leadership. And that is a very, very promising kind of examples are coming from the grassroots political leadership. And if you look at the bureaucracy, that has really been reluctant not to give power to the political leader at the grassroots level. So this is a big hindrance which we have experienced. Even there is a reluctance of the state governments to give power to the panchayats, because they don't want to give every power to the panchayat despite having 11 schedule and 29 subjects. But the decentralized planning, unless it happens from the below, and that is the reason why we are talking about the bottom-up planning. And this bottom-up planning can really make a sea change in the grassroots democracy. And this grassroots democracy is not only democracy, it is going to bring the village development and ultimately culminating into the sustainable development goal. And this is the cycle, how this GPDP is to be prepared. We have had the opportunity to study the actual functioning of GPDP. And GPDP is a very novel and very effective kind of idea, but unfortunately, it has not really been able to percolate down up to the village level, up to the masses, how to engage into it. And as a result, what has happened that there is a very limited understanding of the GPDP. Most of the time, there are two very important aspects. Only it is a wish list. People are just offering their inputs in terms of what is to be done in the village. They are not thinking much in terms of what kind of resource envelope they have at their disposal. And that is the reason why the GPDP has not yet really been able to come out to engage with the issues of health, education, livelihood, ecosystem, biodiversity, agriculture. And there are several other sustainable issues which are to be dealt by the village panchayat are yet to happen. And this is a very important, and I'm not talking because I've already explained the 10 specific goals are directly related to the village. And what can be the takeaway from here? If you look at the SWOT analysis, definitely this grassroots democracy has opened vistas for the rural development, and we can ultimately achieve the goals of sustainable development through the grassroots democracy. There are different weaknesses, there are hindrances, there are bottlenecks, but this is really a big opportunity. And what is the way forward? This is the last slide through which I'm finishing my point, that there are certain individuals or institutions which are creating a kind of bottleneck or negative attitude in terms of decentralization. That is the politicians, the officials, the landlords and feudal elements, contractors and middlemen. And what is the need of the hour? Because we have developed a very, very fine kind of GPDP program, the grassroots democracy, the 73rd Amendment Act, the regular elections, new leadership. But we have not really been able to cultivate all these things in terms of the capacity building, the sensitization, the orientation. And sensitization and orientation is not limiting to the elected representative. It has to happen alongside with the bureaucracy and political leadership and the elites in the rural area. Then only we will be able to. And another very important aspect, you cannot keep everything in your basket at the state government level. You have to have the devolution of 3 F's, funds, functions and functionaries to the grassroots political institution, so that they can think of holistic development of the village at their disposal. And that can happen through the process of breaking the culture of silence. And if this happens in the coming years, maybe in a decade or two, then we will be able to make a very huge change in the rural development, and ultimately we are going to achieve the sustainable development goal by the 2030. So this is all from my side. I'm really thankful for giving me this opportunity to speak on such a
Hello.
Hello. Yeah. Thanks to Professor Yatindra Singh. If there are any questions,
Yes, sir.
Are there any questions in the question box, Dr. Shweta?
Yes, sir. So there is a question which is raised by a student of MSc Environmental Science, Sanjana Bhana, that what are the developmental strategies that enable and catalyze sustainable land management? What are the developmental strategies that enable and catalyze sustainable land management?
Look, sustainable land management is a bigger issue, which is not directly under the purview of grassroots democracy, but we are talking in terms of social capital, and social capital is again dealing with the public land available at the village level, and we have witnessed that most of the time these kind of lands are encroached by the influential individuals residing in the villages. And after the arrival of the grassroots political leadership at the village level, there is a direct control of social capital by the village panchayat, and they are able to address not adequately but partially the issues which are related to the land management at the village level.
Any other question?
Yeah, I just have one question for Professor Yatindra Singh. Do you take into consideration the migration of population from rural to urban? Because I hear that this is changing the um, demography of Indian cities and rural areas. Do you take this also into consideration when you are in your planning?
Thank you. And this is really very important. And you know, there is a pattern of migration. Migration is not happening universally from all the rural areas of the country. This is happening from the pockets of certain areas where in the depressing situation is more. And if you take the example of Madhya Pradesh, the migration is happening from the tribal pockets, because we have recently carried out one study how this migration has made an adverse impact of on the rural people after the arrival of this pandemic. And we have witnessed that there are certain districts wherein this rural migration is happening, and this migration is again, people are, even the Niti Aayog CEO is saying that you have to go fast in terms of making this state urbanization. Urbanization is a symbol of development. But if your urban centers are not carrying the capacity of absorbing this intrudus of the rural masses, then there can be a chaotic situation in terms of infrastructure and everything. So people have started talking in terms of satellite township and all these things, even for the individuals coming to the rural to urban area. But specifically the nature of migration, particularly the labor migration, which is happening from rural area to urban area, is of very different nature. All the families are not going, only few individuals are going, or certain families are going for seasonal migration. Therefore, whenever we talk in terms of migration, we talk about seasonal migration. So people are going after the during the lean time, when there is no agricultural labor demand at the village level, so they are going to the urban center. And we have to think a little louder in terms of how we are going to able to address this sustainable development in terms of the permanent migration from rural to urban. And if at all this happens, then what is going to be the situation of infrastructure available at the urban area, what kind of habitation structure is there, and there are different adverse impact which has happened in the urban areas, not merely providing the labor available at the urban center. So it's a big comprehensive issue which requires a larger debate at the development discourse.
Navjyoti ma'am.
Okay.
Navjyoti ma'am, you're
Thank
requested
you. Over to, I thank all the speakers, and now over to Dr. Shweta.
So may I raise one more question, because one of our
okay, sorry, one more question, yes.
Dr. Preeti Kituria, she has raised a question, so I would ask Madam to read her question. She is one of the panelists. Preeti ma'am, can you?
You can read the question if you have it.
Okay. What challenges government is facing to achieve sustainable development goals in rural India? Though, as you rightly mentioned, that government has various flagship programs for rural development, but still, what are the challenges faced by the government?
Yeah, as I have very specifically mentioned that we have to deal with almost 10 sustainable development goals through the rural development process. And government has always been keen to address all these 10 issues. And what are the bottlenecks or problematic areas? After the arrival of 73rd Amendment Act in 1993, in the last 25 years, it was a big opportunity for the government, both at the center and the state government, that they should have given the opportunity to the grassroots political institution to engage with the masses in terms of all these issues. But the attempt was of half-hearted nature, and that is the reason why I'm advocating that the bottom-up approach of planning need to be strengthened through the grassroots political institution. And if that happens, then if you look at the holistic development plan, there are several issues which are not requiring any kind of funding. Only through the sensitization and orientation of the rural masses, you can make a hilarious change in the rural panorama. And that can only happen when you are strengthening the grassroots political institution. They are supposed to be inculcated in their mind that what are the issues which they need to address. That has not really happened. So strengthening grassroots political institution can be one of the ways through which we can address half of the problem, which is occurring at the village level.
Okay, thank you, Professor Yatindra Singh. Over to Professor Vishal Yardi for concluding remarks.
Thank you, sir. Interdisciplinary session comprising of architecture, life science, and social science can be so interesting that this was never thought of, and this was beyond imagination. Even National Education Policy 2020 focuses on interdisciplinary approach, so we are happy that we are following it. Further, I would like to mention that our university is contributing to the sustainability through Center of Excellence and Sustainable Development under leadership of Dr. Santosh Dhar, Dean Faculty of Research, and coordinated by Dr. Namrata Jain. It can be recycling of paper, it can be plastic-free campus, and so on. We are contributing to sustainability through this center. Further, we are coming up with new campus, and all the buildings which are designed by architect Kreja, there are all the basic principles, may it be daylight optimization, may it be building envelope, may it be weathershed designs, all such major aspects are taken care of. Today's first speaker was Dr. Madhura Yadav, Director, School of Architecture, Manipal University, Jaipur, and the session was on energy conscious architecture and planning. She started the presentation with a strong message that planet is for all and not only for human being. Then she explained Jaipur city and its sustainable approach. She explained all basic principles of designing for sustainability, including orientation, building envelope, building configuration, opening design, wall thickness. Then materials, especially low embedded materials, were discussed. Bamboo as a sustainable material was explained in detail. And further secondary approach like landscaping, how it can contribute to sustainability, then non-conventional resources, and finally she concluded presentation with sustainable goals and their interconnection, that if we try to solve one goal or if we try to solve one problem, then other related problems can be solved. Second session was on impact of climate change and biodiversity and agriculture by Dr. B.C. Tripathi, Professor Emeritus, Department of Life Science, Jawaharlal Nehru University, New Delhi. He explained all basic things like need to conserve the fresh water, 1/3 of we already lost 1/3 of topsoil, increase in carbon dioxide, loss of forest cover and its side effects, human population pressure, many species disappeared and many are on the verge of disappearing. We must manage sustainability for our future generations and so on. So, and the third session was by Dr. Professor Yatindra Singh Sodhya on rural development, whereas he focused on basic rural development, basic things like poverty, unemployment, and inequality. He discussed 10 sustainable development goals which are related to rural development. Indian villages are lacking basic infrastructure was explained in detail, and he also explained a roadmap in a specific way through which we can proceed for the rural development. So I thank all the speakers for their valuable time and for informative sessions. Thank you.
Thank you very much, sir. It's a privilege and honor for me to propose vote of thanks on this special occasion, Sanmantrana, a multidisciplinary international congress on good practices and capacity building for sustainable development goals. I express my sincere thanks to Honorable VC Sir Dr. Upendra Dhar and also to Dean Research Professor Dr. Santosh Dhar for their valuable guidance and support. I also express my sincere thanks to Dr. B.C. Tripathi, Professor, Department of Life Science, JNU, New Delhi, for enlightening us with his valuable words to achieve sustainable development goals. I also extend my gratitude to Dr. Madhura Yadav, Professor and Director, School of Architecture, Manipal University, Jaipur, for her thought-provoking words towards energy-conscious architecture and planning. I am also thankful to Professor Yatindra Singh Sisodiya ji, Director, MP Institute of Social Science Research, Ministry of HRD, Government of India, New Delhi, for sharing his knowledge with us about sustainable development goals, rural development, and grassroots governance issues and concerns. My sincere thanks to Professor Dr. K.N. Guruprasad sir, Director, Shri Vaishnav School of Science, and Professor Dr. Vishal Yadi, Director, Shri Vaishnav Vaishnav School of Architecture, SVV Indore. I am also thankful to all respected directors, HODs from various departments, faculty members, staff members, and technical team members, and also to students. Thanks to one and all. Have a great day ahead.
Thank you.
Thank you so much, sir.
Thank you.